Hello, everyone. Welcome back to the Microcontroller Application Technology course. Today, we will learn about the dynamic refresh display of numbers. Next, we will focus on the following topics. The objectives of this lesson are to understand the principle of dynamic refresh display and use the method of dynamic refresh display to achieve continuous display of 23-19-00 seconds on an electronic clock. Previously, we have learned that the essence of displaying numbers on an 8-digit display is as follows. First, display the number on the first display on the left-hand side. After a delay, display the number on the second display on the left-hand side, then after another delay, display the number on the third display on the left-hand side. Once all 8 displays have displayed their numbers, start over again. The advantage of this method is that it easily achieves dynamic display. However, a delay program needs to be called between every 2 displays, which reduces the efficiency of the CPU. Moreover, if the CPU has many tasks, it might pause the dynamic display of the display while executing other programs, resulting in discontinuous number display. How do we solve this problem? To learn the dynamic refresh display function of numbers, we must first understand the principle of dynamic refresh display, and then try to use this new method to achieve continuous display of the seconds on an electronic clock. We need to use the timing interrupt function. For example, we place the numbers to be displayed in a buffer area first. Let the timer generate interrupts at scheduled times. After the interrupt is responded to, it automatically executes the data refresh display program to display the buffered data, while the main program executes other program statements. Since the interrupt function is not affected by other programs, the scheduled refresh ensures uninterrupted dynamic display. Since the function to be implemented is dynamic scanning display, the hardware circuit diagram is exactly the same as in task 1. Let's mainly interpret the program. The program is divided into 3 parts. The main function needs to complete the dynamic pause after calling the T0 initialization function. The function of the initialization function is to complete the initialization of timer T0. The function of the interrupt function is to complete the second increment function, update the current second value, write it into the display buffer array, and send the bit code and segment code for displaying numbers. Let's look at the specific program statements. Here, a display buffer array is defined, which contains the initial values 23-19-46 corresponding to the segment codes of 8 characters, and the values in the array will be updated when used later. When programming, 5 variables also need to be defined. Secnum is used to calculate the timing of 5 milliseconds for 200 counts. Second is used to calculate the current second value, with an initial value set to 46 seconds. Sec is used to store the high-order value of seconds. Secal is used to store the low-order value of seconds. Count is used to store the number of digital tubes to be displayed, with the first one counted from the left set to 0, and it increases by 1 towards the right. We set the initial value to 0, indicating that the display starts from the first one counted from the left. This is the main function program, which first calls the initialization function to initialize T0. It sends an initial value to the P2 bit code control port. Later, when using the bit code for the first time, it needs to be shifted 1 place to the right to become 7F, that is, 01111111, which is used to select the first display on the left-hand side to display numbers. Then the main function uses a while structure to dynamically pause. This is the T0 initialization function. First, it specifies that T0 operates in mode 1, which is for calculating the initial value of the timer for T0 to time 5 milliseconds. The overall interrupt is allowed, as is the T0 interrupt, and the T0 interrupt is enabled. This is the T0 interrupt function, which triggers an interrupt every 5 milliseconds. After entering the interrupt, the timer's initial value must be reset first, as each interrupt occurs before the timing reaches 1 second. Skip the following 8 instructions. Once the timing reaches 1 second, execute the following set of 8 instructions. The variable counter second is reset to 0, then the second counter second is incremented by 1, and it checks whether it has reached 60. If it has reached 60 seconds, it needs to carry over to the minute value, and the second value is reset to 0. We will learn about carryover in our next lesson. Finally, regardless of whether there is a carryover, we need to split the high and low values of the seconds into 2 separate digits for display, corresponding to these 2 instructions. Then, after looking up and retrieving the display segment codes for the high and low digits of the seconds, they are sent to the display buffer area to update the values of dis_buffer 6 and dis_buffer 7. The next step involves using a right shift method to send the display bit code to port P2 and transferring the contents of the display buffer array to port P0. Then, increment the display number stored in count by 1. If it has reached 8, it indicates that the rightmost display has been displayed, so count is reset to 0 to prepare for the next round of displays. Here we add a knowledge point, the circular right shift function. In this example, the control of the bit code uses a circular right shift function, which means shifting the value of P2 in parentheses 1 place to the right and then reassigning it to P2. This is equivalent to the statement marked with a cross out, which is relatively more concise. It should be noted that the circular shift function is a library function of the 51 microcontroller, and when calling it, make sure to include the header file. Let's now look at the simulation results together. The 2 digits on the far right of the display represent the second value, initially set to 46. 1 second later, it changes to 47, 48, 49, 50, increasing by 1 every second, and after 59, it resets to 00. This achieves the change in second values using a refresh method to complete dynamic scanning display, with the advantage of not occupying CPU resources, allowing the microcontroller to work more efficiently. In today's lesson, you should have mastered the principle of dynamic refresh display of numbers and understood the use of shift instructions. Finally, please reflect on this lesson and complete the following exercises to consolidate the knowledge learned today and further deepen your understanding. That concludes this lesson. In the next lesson, we will refine the hour, minute, and second counting carry functions of the electronic clock. Goodbye.